All of you are instructed to write your section and roll number in the chat box.
हाँ
Okay. We are
बोलिए
just logging this. All of you write your name, just not name, section roll number is enough, and your mail ID. You can write your mail ID also. Okay, so it's 9, 10, 11. So we will start. Okay, so can you everywhere? Can you hear me? All of you, please ensure that you are hearing me. Okay, if it is not, please tell me. All people, please tell me. Can you hear me?
Yes, sir.
Okay.
Yes, sir.
Okay, so we will start with our doubt clearing session. Now, this is about your uh, after the completion of the structure and structure program of structures. Now your assignment is given. I think you should see the assignment, that is creation of a linked list of 3 nodes and creation of the linked list of n nodes. Okay, so these two program you have to do today, right? So for that, what you need to do, essentially you need to understand the concept of structure and the concept of linked list, and perhaps the most important thing that you should understand is the concept of self-referential structure, because basically when you try to implement a linked list, we generally use the self-referential structure. Okay, so in the previous day I have already discussed with that self-referential structure. I think all of you understand that. And I have given some lecture to you, that is oil cells lecture, and there Sir has told you that how you can actually create, or how, what is basically the concept of linked list. Okay, so from you, can anyone tell me that what is actually a linked list? Anyone from you?
Non-contiguous allocation of data.
Non-contiguous allocation of data. Okay, they're very good. So it is, you can say this is a prime definition. Now we can also elaborate the concept like that. That a linked list is basically known as a very kind of a data structure, is an elementary data structure which is non-contiguous definitely, and also it is created as a dynamic data structure. It is also created as dynamic data structure. Now what do you mean by dynamic data structure? Dynamic data structure means whenever user wants to create or user wants to store a data, it will store in a particular node. Okay, so the primary element of the linked list is node. Okay, you have to understand that the primary element of linked list is basically called as node, right? So we have something like this. Mm, you can see the, I think you can see the whiteboard. So if we consider this particular box, something like this, we can consider this particular box as a node of a linked list. Okay, in general, if we have two in a linked list, in general, a node having 2 parts. Okay, so this is the node. So how many parts are there in the node? There are 2 parts. First part is the data, and second part is known as address part. Okay, second part is the address part. So this is the primary concept of linked list. Okay, so this type of linked list here, this type of node is perhaps known as the singly linked list. This type of node linked list is perhaps known as singly linked list, where there is maybe one or maybe more than one data part, but there must be one address part. Okay, there must be one address part. So fundamental concept of linked list building blocks is uh, actually based on this. That is, your the node must have a single address part. Okay, node must have a single address part. All right. So that means what? That means we can create another node like this, similar like this, another node say. Okay. So like this, we can create the n number of nodes. And what we can say, suppose the address of this node is say x, address of this node say y. Okay. So what I can do, I can store the address this x into this location. Okay. So that I can say that this particular link will be formed. Again, the same thing, address of that y address can be stored here, so that a link can be formed between them, right? Is it clear to everyone? Is it clear to everyone? And all of you see this now. First of all, you just tell me, and all of you have see this particular thing on. Okay, so here is basically the fundamental concept of linked list, that yeah, this is always a kind of a linear data structure, but with having the dynamic data structure, and nodes can be created dynamically. Okay, nodes can be created dynamically. And when you are dealing with a single linked list, it means that a particular linked list consists of the node, that node which consists of a data part as well as the single address part. Okay, so this is the main concept of the linked list here, right? Okay, so over here, over here, I want to ask you, starting from uh, Mr. Akash Das, section G, roll number 9. Are you present? Akash Das?
Yes, sir.
Okay.
Yes, sir.
So can you tell me, have you seen that diagram, that how actually the linked list looks like?
Yes.
Have you seen that? Okay. So how many address part will be there in the single linked list?
Single link is only one address part
One
will be
address
there.
part,
There
okay.
can be more than one data part.
Okay. Okay. So now our question is that how you can actually create that node? Okay. How you can actually create that?
Create that
So
node means.
can you tell me how can you create the node of a link? So can you tell me the answer?
Yes, in get node we create that we make that get node function, and then after that
Get node function is fine. Get node function, but basically, what is the primary structure to create the linked list? In order to create a node of a linked list, what you necessarily need, you need to have
we need a data
structure.
part and the address part.
Yes, but
Selfless reference string structure means address part, and then we use get node to get a dynamic memory of that, and we push and using and we store the address in head. Fast address we store in head, and then we push the data by
not push, actually you just store the data. Push concept
yes,
is a separate concept, that is about your stack. Okay, okay, thank you. Okay, thank you. So
sir, I have a question.
Yes, tell me.
So that is in the get node, in the main, in the void main, we are taking an input, right? Scanf %d and then.
Yeah.
And after that, when we are calling the get node function, right? We are also then taking another input. scanf person
Yeah,
and
that
item.
you can do. That you can do. That you can also do. That
I am saying, sir, why I am
tell me.
why I am taking another input means when the user is giving an data, I have to create a node, right? So for that we are using the get node function. So why are we taking another input called
See,
item in the get node?
in general, the design of the program is something like that. That first of all, you have to create your head node, and after that, you can call the get node function and create further nodes. Okay. So as per your requirement, how many times you want to create new node, based upon that you can call your get node function and you can create a new node. Okay. So that can be possible. But I will also give you another sample code so that you can easily understand that in a single program without writing any function get node, you can directly access or we can directly create the node of a linked list. Okay. We just create the head node once and then repeatedly we can create the dynamic nodes as per our requirement. Okay. So I will give you that particular, I will show you that particular. Okay.
Okay, so thank you.
Okay. Okay. Now Abhay Gupta. Are you present, Abhay?
Yes, sir.
Okay. Abhay, can you tell me that whether when you create a linked list at that time, if we create multiple number of address, then what will be the result? In a single linked list, how many address part is there primarily? Can you tell me? Abhay? Hello? I think Abhay become silent. You can mute. Hello, Abhay, can you hear me?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
can you whatever question I've asked, can you give me the answer? That if we have multiple number of nodes in a linked list, then is it possible to create a single linked list?
Yes, sir. Linear variably, matlab linear means linear
No,
vary
it's
one by one.
essentially how many address parts will we should required in case of a single linked list. I've already shown you the diagram.
Initially one, sir.
Initially one. Okay. So one. Okay, fine. Thank you. One of the major concerns is just that in case of a single linked list, definitely we have uh, one address part, right? So one of the disadvantage of that is something like that, that we can basically traverse the linked list from from one direction, that is within a single direction only. Okay. If you see that diagram, you can easily understand that if we this is my head node, the first node, it is basically the head node. Okay. If this is the first node, then we can, if as my address of the next node is present over here, so I can directly go from head node to the next node. Okay. Then from the next node to next node of this. Okay. And so on. In this way, actually, we can traverse from one node to another node, right? But reverse traversal, that means from this node, that means from third node to second node to head node, it is basically not possible in case of single linked list. Okay, it is basically not possible in case of single linked list. Okay, so that's why basically there is another technique is there, that is known as doubly linked list, that we can implement. Okay, if in order to reverse tracking. Okay, but mind it always that when you use a single linked list, you have to traverse from one direction, from head to the next values. Okay, next step. Now, sometime maybe you can ask that, sir, if you want to traverse to head node again, that's what I can do. Essentially, what you can do, you can create a circular fashion, so that suppose my head node address is say K, and you can store that K into the last node address. Okay, so that it will be circularly accessible. It will be circularly accessible like this. Okay, so if this is the scenario, then you can say that this particular linked list concept, this particular list is basically a circular list. Okay, where the last node's address part is actually pointing to the head node. Last node address part is pointing to the head node. Okay. So this concept is pretty much sometimes useful when you want to create a circular kind of link list. Okay, but in general, we are not generally use the circular link list. In that case, what happens? The last node address part should be null. Okay, last node address part in that case may be null. Okay. So you have to understand the concept of that. That how, when you have to create circular node, circular list, when you have to create the normal linked list, that is only the last node address part become null. Okay, so these are the two main concept that maybe we use in general when we create the linked list structures, right? So these are there are other things that are like complexity, that what is the time complex and all that. I will not going deeper into that. And in your syllabus, generally the single linked list is there, double linked list is not there. Double linked list is basically in your second year syllabus. Okay. So now we are just going to the coding part, that how you can actually create the code for the same. Okay. So there are two codes I actually try to implement. The thing that we have already told you in the previous class, as well as your assignment, whatever the assignment has been given to you. That is these very programs are there. So first program is that create a simple linked list using 3 nodes only, right? Simply linked list with 3 nodes, right? So what you should do, you should essentially create the structure. This type div struct L. Now just see the structure. The structure is of a self-referential kind. Okay, structure is of self-referential kind. Okay.
Screen is not visible.
Yeah.
The screen is not.
Screen is not visible. Okay. Okay.
No.
Just wait. Okay. Now you just tell me whether it is visible or not.
Yes. Yes. Yes.
Is it visible?
Yes.
Okay.
Yes.
Okay. So essentially, you can see this is the part that is 3 different node you have to create. So you have to write your type div struct L first. That is your the self-referential structure itself. Okay. Now here I have already explained to you that why it is a self-referential structure, because this particular structure consists of a pointer which points to the same type of structure variable, which points to the same type of structure variable. That means which can able to store the address of same type of structure. Okay, so that's why it is a self-referential structure, right? And it is the name of the data type is node here, right? So when you create this, you have to create the pointer of that node type, right? Achha. And one thing I just want to tell you, that you have to write stdlib.h header file. For that you can define a null like this, has defined null, whatever. It is kind of a macro where if you write null anywhere, it means that it will become a 0, right? So that is has defined null, you can write it. Okay, in order to understand the last node of the linked list, so that we can store the null or 0 at the last node address part of the linked list. Okay, so now you see the main function just. Okay. So this is the main function. So what is actually written? You just creating the variable head, n1 and n2. Now these 3 variables are basically used for creation of the nodes, 3 nodes, right? So head equal to, you just see head equal to node star malloc size of node. That is the head node creation. Okay. So the starting node or the first node of the linked list is basically known as the head node, right? So first of all, you have to create your head node, right? Or sometimes known as header node, right? So this node you have to create first. So I'm just taking the data for head and then printing the, scanning the data as a D and then store that into head arrow data. So head arrow data is basically the data part of the head node. You can understand. After that, I am writing n1 is equal to malloc node star malloc size of node. That is we are trying to take another data into another newly created dynamic memory, right? So printf entered the data for new one and then take the data into new one arrow data, right? So this is the second node. Third node, again you are creating malloc function and allocating the memory and then again storing the same data. Okay. So intentionally I am actually calling malloc function 3 times so that you can understand that how individual node is get allocated. Okay. How individual node is get allocated. 3 different node, 3 pointers, structure pointers are there. Based on 3 different structure pointers, 3 new dynamic memory allocation has been created here, right? 3 new dynamic memory allocation has been created over here. And then what you can do, you can store the data corresponding to each and every node. Okay, that means the data part will be stored. Okay, now what you need to do, you need to make the formation of the link. Okay, you have to make the formation of the link here. Okay, so what essential thing that you need to do? You have to store the addresses of each and every nodes into its previous node. Okay, into its previous node, right? So our configuration is something like that. That is like this, whatever we have discussed here. If we consider this is head, this is our new one, and this is our new two. Okay. So there are 3 nodes. So first node is your head, second node is your new one, and third node is new two. So what you need to do, you have to store the address of new one into the next part of head node, as well as you have to store the address of new two into the next part of new one. Okay, and the address part of new two, that is your last node address part, should be null or 0, so that it will signifies that it is the end of the list. It is signifies the end of the list. So this very configuration actually we are going to do. Okay, this very configuration we are actually going to do. So in order to do that, what
Sir,
yeah.
Sir, can we make nodes by making multiple functions?
Yes, pardon?
Can we make nodes, multiple nodes by making multiple functions?
Multiple nodes by using multiple function. Means I'm not
yes, sir.
getting your point.
Sir, make like we created a like function get node, then we can create more function like get node like any name, and then we can create more nodes by linking them.
But why should we go for that? Because node are of same types. So definitely you have to create only single function. We do not need to create multiple number of functions for a single type of. Okay. If the type of nodes are different, then definitely it might happen. But in general, that is not supported. Okay. In general, when you create a linked list, you have to use the same type of node or same nature of nodes. Okay. The node, the building block or blueprint of the node is basically a similar kind, right? And this is a practical use. Okay, if you make a different type of node in for a particular link, it is also possible. Not like that, this is not possible, but you have to make same characteristics of node in general, right? Right. So now you can see that 3 lines of code. These 3 lines of code is actually making that formation of the links, right? So first, what you need to do, head arrow next equal to new one. That means your second node's your second node's address, that means new one's address, will store into the head next part of it. Okay. Then what you need to do, new one arrow next equal to new two. New one arrow next equal to new two. That means the address part of the link new two node, address of new two node is actually get stored into the next part of new one. Okay, so new one arrow next equal to new two. And finally, what you need to do, you just write new two arrow next equal to null, so that your next part of last node, that is new two, will become 0, and it will conclude as a termination node or the end node corresponding to your linked list. Okay, so 3 node linked list will be formed. Okay, now your task is what? Your task is to just create or print your linked list. Okay, so in order to print the thing, what you need to do, you just use that particular pointer. Okay, so this card pointer is mainly used for current node. That means it will point to the current node. So initially we'll start from head node and we'll traverse from starting node to the end node. Okay, so that's why just initialize cut to head first, and then we are just writing a simple while loop car not equal to null, then printing the data, that is printf car %d car arrow data. That means whatever it is pointing to the node, whatever the car pointing to that particular current position of the node, the data corresponding to that will be printed, right? And whenever it prints, it will immediately update the position of the pointer, that is car equal to car arrow next. That means first of all head node. After that car arrow next means it will head arrow next become the next node. After that car arrow next, it will be the next node, and that. Okay. So in this way, until unless it will card will become null, that means the end address, it will become print the entire set of structures, right? So you can execute this program. If you want to run this program, it will be something like that. Okay. Just a minute, I'm just sharing the screen of execution. Okay, so I think now you can see, enter the data in head. So I'm placing 12. Okay, enter the data in new 1, so 13. Enter the data in new 2, 14. Okay, so it is showing the list data 12, 13, 14, then end. Okay, so this is the primary execution, that how we can create the basic list, right? After this, we can create, or we can show you the multiple number of nodes. Now, if you want to create multiple number of nodes, then what it will be? If we want to create multiple number of nodes, then it is better to create the head node first. Okay. Same linked list, same structure we are going to use. Okay. Then there are head, star new 1, only 2 values are there, and start. Okay. Then we are taking a head node first. We are creating the head node here. Okay. After that, we are having a while loop. See. Now, within this while loop, you are actually creating a new node one after another, one after another, one after another. Okay. Based on this loop condition, that whether you want to create another node or not. Okay. So here I'm writing printf, do we want to create another node? Yes or no? If it is yes, can I process C and process CH? So if it is yes, then the loop will again and again run. Okay. If you press N, then loop will terminate and your system will actually stop and end of the creation of the linked list, right? So within this loop, you can see I'm just entering the data, and I am creating the new node here. Okay, and each and every time I am using this current pointer. Okay, so car arrow next equal to new 1, because current pointer holds the last current location, and you have to insert a new node after the last current position of the node. That means whatever the current node is, its last position, in the last position of that node will get inserted by this. Okay, so that's why I'm writing, instead of writing head arrow next, I'm writing car arrow next equal to new 1, and new 1 arrow next equal to null each and every time, because you don't know then when your loop will stop. Okay, because it's an undefined, or you can say a sentinel kind of loop. Okay, so you have to write new 1 arrow next equal to null, and then you have to write car equal to car arrow next. That means you are incrementing your car pointer to the next node, that means newly created node, right? So in this way, if you write this particular while loop, and each and every time you are within the while loop, you are creating a single node, then it is possible to create n number of node at a time. It is possible to create n number of node at a time. Okay, so And whatever the printing operation, it is similar with the last printing operation, whatever I have discussed. Okay. So only you have to concentrate over this particular line of codes, that how you can actually create a new node within a single loop. Okay. And as per your choice, whether you want to continue or not, a new node will created again and again. Okay. So let me execute this particular code once. Compile and execute. Okay, sharing the screen first. Okay, so just see. So enter the data for head. I'm writing say 12. Okay, enter the data for new node, say 23. Then it is asked that whether you want to create another node. I'm writing yes. So again enter create another node. Again it is asking for that. So I'm writing another. Yes, another. Yes, another. Then I'm finally writing no. Okay. So as you are pressing enter over in this case, you can see your entire list has been actually displayed. Okay. So this is the alternative way through which you can actually create n number of nodes in a linked list. Okay. So I'm just sharing the code again. It is better if you try to write it down because time is short, only 6 minutes left. After that, we can automatically log out. So this, you just see this particular while loop, okay, with the car equal to head, because here also we have to use this current pointer, right? And that current pointer will start with the head location, okay? Then your loop start while ch not equal to n, enter the data for new node. Then you are creating the dynamic memory for the new node. After that, storing the data into new node. And these two lines are pretty much important here. That is, what you are writing, instead of writing head arrow next, you are writing car arrow next equal to new one. Why? Because at the beginning, when car equal to head, it is nothing but, you can say that car arrow next is similar with the head arrow next. So head arrow next equal to new one in the first iteration. And new one arrow next equal to null, okay. Then you are asking for, do you want to continue? Yes or no? If it is yes, then car equal to car next will happen. That means head will point to the next node. Okay. The car pointer will actually start jumping from head node to the next node, right? And as it's jumping to the next node, it is again asking for another new node again. Okay. So the loop will iterate, and again it will create allocate memory against the new, and then it will create another particular node. Okay. So in this way, you can create multiple number of nodes. Okay. This is the simplest way. We're not using any kind of get node or any function. Okay. Within a single main function, we are using a while loop, and we are creating the n number of nodes of the linked list. Okay. I think it is clear to everyone. If it is not clear, please tell me any doubts. Okay. There are 4 minutes left, so you can check out the doubts, and after that, as we are logging out, we can you can start your online IMCLB test and start your assignments also, right? So please tell me whether you have any doubt. Anyone? Anyone?
Can you please share the code with us?
Okay, this particular code. Okay, then definitely yes, I can share. First of all, you just try it once. Okay, you can make a screenshot of that. Okay, first of all, try it once.
I made some screenshots.
But after that, definitely we will share the code. Okay. I think 3 node linked list is understood easy. It is, you can easily do that.
Yes.
But with n node with simple, that means there is no get node operation at all. Just write a simple while loop. You just create the n number of node with this, right? So I think I will definitely share it. So now I think if you don't have any question, then you may log out. but what is your next task is to start doing your assignment, okay, and just try to create n number of nodes of the linked list. Next, afterwards, I will share the code. Try to create the n number of node in linked list. 3 node in linked list is pretty easy. You can do that. Okay. And definitely you can have to appear for the test because there are 15 minutes left, I think, to time out. So now it is time to appear for the IMCRP test also. Okay. So I think we should now conclude here. So in the next class, we will further discuss further things. Okay. And hopefully your syllabus will be also over by this or next week. Okay. Okay. And so you have to study it very hard. Okay. So anyway, so thank you everyone for joining. So thank you and goodbye, and just try to solve the question answers and submit it as soon as possible. Okay. Thank you very much.